So let's take a look at our plates map, plates that are the crust around the planet. We've got areas of transform boundaries that we're going to look at in just a minute, but the activity that you're going to do afterwards is kind of more related to transform boundaries that are found as part of other plate boundaries, like divergent plate boundaries. An example of that is on this plate boundary between the Eurasian plate and the North American plate, we have a divergent boundary. Plates are moving apart from each other, but because of the shape of the boundary line, there are some areas where that movement is actually going to be in the opposite direction, side by side, or across the plate boundary, as in a transform boundary. But we'll come back to that a little bit later. Don't want to confuse you too much on it. Let's just look at three areas and then kind of focus on one of them. Three areas where we have transform plate boundaries. One of those is involving the Australian plate and the Pacific plate. And right along here, these islands that are there, that's New Zealand, typically broken up into the North Island and the South Island. And the South Island is basically bisected by this plate boundary. It goes right through the middle of the island. And we have those plates moving in opposite directions across that fault line. So that's a classic transform plate boundary. Another can be found in Europe, in the country of Turkey. But the one that we're going to focus on the most here in this lesson is the plate boundary in between the North American plate and the Pacific plate, right in this area right here. So I'm going to go ahead and zoom in on that area. So this is where we're talking about. If you know our states, we're in California. So the North American plate and the Pacific plate are both moving, and they are moving in opposite directions across the plate boundary. So the Pacific plate in this area is moving to the northwest. The North American plate in this area is moving to the southeast. And this line in between those two plates is our transform boundary. So we can see the arrows in the opposite direction across the transform boundary line. You may know this area more familiarly as the San Andreas Fault. Let's go ahead and switch to another picture of that real quick. So the San Andreas Fault, maybe the most famous fault line, certainly for Americans, runs through, starting down in Mexico and Baja California, runs up through the middle of the southern part of California, heads over closer to the coast, and eventually leaves the coast of California and enters into the Pacific Ocean. But this fault line can actually be traced about 1,300 kilometers long. It's really a series of multiple faults that are combined together to make this famous San Andreas Fault. But there's some really cool things going on here, some really kind of weird things to think of, because there's two huge cities, two really important American cities that are right along this fault line. We got Los Angeles down in Southern California and San Francisco in Northern California. Well, if you kind of see where they are, Los Angeles is to the west of the San Andreas Fault line. San Francisco is pretty much right on it, but it is on the east side of the fault line. So here we have the Pacific plate that is sliding about 5 centimeters per year to the northwest. And then we have the North American plate that is being rubbed on by the Pacific plate and moving downward. If you kind of fast forward in time, several thousands, millions of years possibly, Los Angeles is going to continue to move with the plate northward. San Francisco is going to slide down further southward. At some point, those cities are going to meet side by side. There may be some distance between them, but essentially be at the same latitude, side by side. And eventually, Los Angeles is going to become a city of Northern California, and San Francisco would become a city of Southern California. Pretty crazy, because people in California, they have kind of two different frames of mind between Southern California people and the LA kind of lifestyle versus the San Francisco lifestyle of Northern California. So pretty cool that they're going to trade spots or pass by each other over time. But that's quite a ways in the future. I don't think we're going to see that happen in my lifetime for sure. Let's head back over to completing our notes real quick. You had your top third of your notes where you defined transform boundary, described its prefix. We wrote down or drew the action involved of the plates moving, and then what was causing that with the convection currents in the mantle. So the bottom section is going to be all about the result. So the result of these plate boundaries are going to be changes to Earth's surface or events that can happen on Earth's surface. So I'm going to need to start by drawing in a couple of pieces of rock, some tectonic plates. We'll draw them side by side again in our notes, and we'll draw the movement of the direction of their movement. So they should be going in opposite directions across the fault line. Transform, trans means across. So we got our plates sliding past each other, but it's not like these are like skiers that are their skis are just sliding effortlessly along the snow. This is a really rough, a very violent kind of rubbing on each other as the plates are going by. These are chunks of land that are up to 50 to 100 kilometers thick of rock, and they're being pushed by these powerful convection currents in the mantle underneath of them, but they're also not completely smooth and flat like I've drawn in with these three-dimensional boxes that I have right there. So what happens because of that is that the jagged parts of the rocks between the plates, the uneven areas, are going to get caught on each other. And what that ends up doing is building up a force called tension. So tension is like a resistance to movement. It's like the forces are there trying to get them to move, but they're holding on. They're stuck together, and it's just building up that tension. You think of a rubber band. You stretch a rubber band out. It's got a lot of tension. If you let that go, it's going to fling forward. So tension builds up. At the plate boundary. Now, as this tension builds up, think of that rubber band being pulled back further and further and further and further. There's a certain point where that tension is going to be released. And once that happens, we're going to have our result happening. Let me slide that up so I got some more room to draw. So I'm going to start by drawing one of my boxes again. And this one's going to be the one going forward. And the one that's going backward, we're going to try to put it as having already moved backward. So you can see the chunk of land here on the left side has slid forward, the chunk of land on the right side has slid backwards. And after that tension has built up and built up and built up, and it releases it, this is a sudden movement of a huge chunk of rock. Any sudden movement of a huge chunk of rock is what we would call an earthquake. So our main result from transform boundaries are earthquakes, and the San Andreas Fault is incredibly famous for earthquakes that happen there. So we're going to go ahead and write a little statement here. Let me try that again. Sorry about that. All right, so what we got there, eventually the tension is released and the plates suddenly move, causing earthquakes. Let me set the camera down and I'm going to try to show you an example real quick, a little model example. So I'm going to try to do this where you're looking at it from above. So you can see there's some sort of a stream that's there. we have a fault line, a crack in Earth's crust. So that's like the San Andreas Fault. One of my hands is controlling the Pacific plate, and one of my hands is controlling the North American plate. Well, as they are pushing on each other, rubbing on each other, sliding, trying to slide past one another, moving in opposite directions across the plate boundary, at first, the uneven edges of the rock are just kind of building up tension. They're stuck together. They're not allowing the rocks to slide, even though the forces are trying to push them. But all of a sudden, all at once, when the tension is too much, it has to get released, we get the sudden sliding. And the plates slide in opposite directions across the fault line because it's transformed, and that would have been an earthquake. And we can see that the surface is going to be deformed by that. It might change courses of streams, roads, ridge lines, property lines. All those kinds of things can be shifted as a transformed boundary allows the tension to be released and earthquakes to happen. So transform boundaries, maybe not everybody's favorite, especially because they're kind of scary. You know, people that live in San Francisco, like my brother and his family, you know, they're constantly aware of the possibilities of earthquakes. Southern California, same kind of thing. So it's important to know and learn more about transform boundaries. We want our scientists to understand the movements of Earth so that we can better prepare for those changes to Earth's surface. But I just wanted to stop and teach you a little bit about transform boundaries and tell you that science rocks. Peace.